Now, we have seen the word equivalent before in set theory. Two sets are equivalent if the cardinality of the first set is equal to the cardinality of the second set. Cardinality would simply mean the number of elements in the set. We don't expect the elements to be the same. All we expect is the cardinality is the same. That is equivalence. Equal sets would mean the cardinality is the same and they must have the same elements. If the first set had cat, dog, elephant, the second set must also have cat, dog, elephant. That would make the two sets equivalent. Equal. Equivalent, on the other hand, only requires the cardinality to be the same. So you could have a set 1, 2, 3 containing elements 1, 2, 3. Another set containing elements cat, dog, elephant. So both of them have 3 elements. They are equivalent sets. Equivalent logical statements produce the same truth values for all cases. Oops, that is the key word. It has to be for all cases. You can't simply say, oh, I picked 2 and it works for 2 of them, so they are equivalent. Not true. Every possible case that you pick, they must result in the same truth value. Let's take a simple example. I'll start with this one. Mind you, I mentioned the importance of parentheses, especially with logical statements. In the first statement, compound statement, I have P and Q. I'm negating the entire statement. The latter part, I'm negating P, doing logical OR with the negation of Q. So I'm going to start with P, Q. They have 4 possibilities. Both of them are true, have true, false, false, true, false, false. I am going to find P and Q. P and Q is true only when both statements are true. And that is only one case, which is the first one. The rest are all false. Now, I want to negate P and Q. So negation of P and Q. So if I negate true, I will get false, then negate false, I'd get true. So true, true, true. So the first case is right here. Now, I want to negate P, want to negate Q. So if I negate P, the true becomes false, false becomes true. negate Q, same, false, true, false, true. Now we want to find negation of P or negation of Q. In other words, the disjunction of not P and not Q. So since I have a conjunction, I only require one of the two statements, not P, not Q, to be true. Well, in the first case, both of them are false, so it's false. The rest, true, true, true. So those are my values. If you look at my poorly drawn red squares, both of them, both columns have the same truth values. So these two have the exact same truth values for all possible values of the individual statements P and Q. There are only 4 possible permutations, combinations. So we have determined that the negation of P and Q is equivalent to the disjunction of not P and not Q. So are the two statements equivalent? The answer is yes. So I'm going to start with negation first. I'm going to go ahead and write the negations of P and Q. So the truths would become false, and the false values would become true. The first compound statement is not P and Q, which would mean I'm looking at column number 2 and numbers 2 and 3. We know a conjunction would result in a true value only when both statements are true. So false, false, true, false. So that is my first compound statement. The next one, I need to find not P or not Q. So an or statement is a disjunction. For a disjunction to be true, one of the two statements need only be true. So rows 2, 3, and 4 have true values, and all we need is one of them to be true in columns 3 and 4. The first one is false, everything else is true. And the next case is P and Q. Again, in a conjunction, if we want a true value, both statements have to be true. So only the first row is going to produce a true for P and Q. So true, false, false, false. And lastly, we have the final statement, the bidirectional statement, combining that column and that column. We know we will get a true value in a biconditional statement, the bidirectional connective, if both values are the same. So either you could have true, true, or you could have false, false. every other case, you will have false. So I'm looking at not P or not Q. None of the cases have the same truth values. So they're all false. So that is our second, oops. So boxed up columns, the truth values of not P and Q does not match not P or Q if and only if P and Q they're not the same. So not P and Q is not equivalent to not P or not Q if and only if P and Q.